Good all. Students, kindly inform to your friends to join the session. As we can see, there are very less participants. Like, we know that you have an holidays and all, but still this session is online, right? So they can attend it. Kindly inform your friends to join the session as soon as possible. So we are starting for the day. Shashank sir, you can take over the class.
Sure, ma'am. I'll start.
Yeah.
Fine. So good evening, everyone. I hope you had a good festival and all. So let us continue from what we have left off. You know, so yesterday we were discussing about the decision trees, right? And today we'll have a continuation on the topic of the decision trees. The continuation topic is nothing but the random forest. So random forest is, like a continuation. So we'll discuss that. So let me share. I hope you have the data set yesterday. What I've shared. So that data set only we are going to use for random forest as well. Okay. So it will be clear for you to understand how the implementation part is also almost similar but little different when it comes to decision trees and random forest. So that data set anyway, you can keep it with you, and when we start the practical, you can use it. So let me share my screen. Okay. So let us start by understanding first that what is a random forest. Okay. So how is it different from decision trees, and how random forest plays a very important role, right? So we will understand through a step-by-step process. Okay, so now let us see what is a random forest. So a random forest is basically a very popular machine learning algorithm, I can say. Okay, because decision tree itself is very famous and very numerous applications or very high applications we can see when it comes to decision trees. But as we have discussed yesterday, there are some issues with decision tree which are actually overcome, or which are overcome by the random forest. So that is why instead of decision tree, what happened is random forest became more popular. Okay, so the two people who invented the random forest algorithm basically are Leo Breiman and the Adelie Cutler. So now let us go further, that why or what is the use of using a random forest. So as we already know that a decision tree can do both classification and regression, right? So on that basis, you can also do classification and regression for random forest as well, right? So this is a very important aspect because there are very few algorithms which can do both classification and regression. In that, two main algorithms are decision tree and random forest. So next is the strength of the random forest basically lies in handling the complex data sets. So handling a huge amount of data, right, and trying to avoid that overfitting or to mitigate the overfitting and predict the outcome, right? And this is what the specialization of, or I can say the speciality of random forest lies in. So it can handle, as we already know that, it can handle both categorical data as well as a, numerical data. So it can perform both. Okay. Now let us go to the next part where we can see the applications of random forest. Okay. Let's go ahead. Yeah. So let us see some areas where we can see the applications. So one such area is nothing but the customer churn, right? So when we have to identify, right, that the right kind of customer, or whether the customer will basically what is churn is whether a particular person will continue something or not. Okay, so if here I've given one example, like a businessman, yeah, whether he will continue his service or not. So it might be anything. Here I've mentioned, telecom company. For example, based upon your usage, right, the amount of charges you are paying, right, in the long run, whether you'll be able to continue that particular mobile network or a telecom company is what the analysis can be done using the random forest. And then the fraud detection. So fraud detection is one such area, as I already told you, where the decision tree and random forest actually excels very well. So when it comes to the fraud or in the finance domain, the tree structures such as the random forest and decision tree play a very important role in identifying the fraud detection in the real-time industry. So next is predicting the stock prices. So as we know that this is also capable of doing a regression, is also capable of doing a regression. So obviously we can predict a value which is a continuous value. For example, like a stock price prediction. So next is the medical diagnosis. So again, here we can use that again random forest where we can predict the disease. So whether it is whether the disease is existing or not, or we can identify that how or which level the disease basically is based on the certain characteristics and parameters. So next is image recognition. Even for image recognition, we can use the random forest. So which is which can be also used in the self-driven cars. So next is a real life analogy of a random forest. So the most important or a very small application we can see. So we'll get a brief idea about what exactly happens in random forest, or how does a random forest actually turn out to be. So here we'll see a very small example. So a student named X wants to choose a course after his 10 plus 2, right? So he has finished his 12th, and he wanted to choose a particular course, and he cannot decide which course he actually fits in because of his, or what kind of skill set he's actually having. So he decides to consult various people like cousins, teachers, parents, right, degree students, and working people. So even we would have done that, right, at that particular age, right, to know which kind of course actually suits us, because we will be having multiple thoughts. We can do this, we can do that, right, but what is the exact uh, you know thing which actually suits us, right? So he asked them varied questions like, why he should choose a job, choose job opportunities with that course fee, etc., and so on. So after consulting various people after the course, he decides to take a course suggested by most of the people. Okay, so that is what he actually has done. Now, how working can be done, right? So before understanding the working of the forest, random forest, we must actually understand what is an ensemble technique, right? So what is an ensemble? Why we are actually whenever we talk about the word random forest or random forest algorithm, the most important word which comes to mind is the ensemble or ensemble technique or ensemble learning technique, we can say. That's actually the correct word, ensemble learning technique method. Right. So what is this ensemble method, right? The most important why we use this word is basically ensemble methods are nothing but a combination of multiple models or a multiple methods, right? Why we use this is sometimes, right, in certain scenarios, a particular model will not be suitable to do a particular prediction, right? So in that case, what happens is we go with the ensemble techniques. So there are a lot of ensemble techniques, and we are going to discuss in the further, sessions as well, right? But we are going to start with the first and the foremost and a very important ensemble technique, which is random forest. Yes, you heard it right. Random forest also comes in the ensemble techniques because it is not a separate algorithm. It is a mixture of multiple models, right? Like the bagging, right? And then the decision tree also included in the random forest. So it is basically a collection of multiple models built into a particular algorithm, is basically called as an ensemble method. And the foremost and the very important ensemble technique in all the ensemble techniques is the random forest. Okay, so let us go to the, there are two important, uh, sorry, there are two important things when it comes to the ensemble techniques, right? So we'll see based on the kind of algorithm, how it actually gets implemented. So there are two kinds. One is the bagging, one is the boosting, right? So bagging is nothing but, it's a kind of mechanism or base, in a very simple, I'll tell you in detail as well, but in a very simple understanding what is bagging is, basically bagging is nothing but a random sampling. But in bagging, the most important thing is the random sampling is done with replacement. So actually, when it comes to a sampling technique, right? So when you actually sample a data, right, there are two things. One is random sampling with replacement and random sampling without replacement, right? So with replacement is nothing but when you choose a particular sample from a lot, and you take that particular sample into the sample list and you put it back. You put the sample back into the lot. That is basically called as a random sampling with replacement. So you're replacing that particular sample into that particular lot. And when it comes to the next thing, which is random sampling without replacement, for example, you have 10 balls, or 10 10 boxes, right? You are taking one box. So if you are not using with replacement, right, so it becomes 9 boxes after you take one box. For example, if it is with replacement, you are choosing that sample again, you are putting it back, so it will, the original number again comes back. So then what does our random forest use? Random forest uses the bagging method, which is, random sampling with replacement, right? So how does it work and all, we are going to see. So it is random, some algorithms use bagging concept, some algorithms use the boosting concept. Okay, so when time comes, I'll tell you what is a boosting concept also. But when, first try to understand what is a bagging concept. And our random forest uses the concept, or it runs on the principle of bagging. Okay, so let us see now, as I have given a brief introduction about what is a bagging. So bagging is basically it is basically an ensemble technique, right? So here what happens in a bagging is, basically, as I told you, we are going to choose a random sample, and what we are going to do is we are going to put it back. Okay, now, there is a clause here. What should we do? Right? So here what happens is, we actually call it as bootstrap aggregation. This is the key word what we apply for the samples. We call it as bootstrap aggregation. Now, what is the most important thing to remember is, we select a particular sample, right? For example, we are choosing, let us say, let us go with a simple example. Let us say our data set consists of 1,000 observations. Okay, very simple example we'll talk. So then you'll be understanding what exactly happens in bagging. Okay, so it's very easy to understand. Okay, just one, if that's one thing you have to understand is, you should be aware of what is sampling technique first. Then it is very easy to understand. So let us say you have 1,000 samples. Okay, sorry, 1,000 data. Okay, in your original data set. You want to apply random forest. Okay, so you want to apply random forest. The most important thing is you have to apply the bagging concept. That is definitely for sure. That is what makes the random sample more, a very good algorithm. Okay, so you cannot run a random forest without using a bagging concept, because random forest itself runs on the concept of bagging. Right now, you have to, or you want to build 10 samples. Okay, so 10 data sets, 10 data sets of 10 samples. Okay, now here, 10 different data sets. So for example, N1, N2, N3, N4, like that, you want to build some 10. Now what happens is, usually what is sampling, tell me? Usually if there are 1,000 observations, you want to do a sample. For example, you have used a sample. See, there is one more clause. Okay, so those who have studied statistics will definitely understand what I'm trying to tell. Because when you do sampling, if you have 1,000 data, 1,000 data in your original data set, you cannot decide that you can take 50 samples, or 50 data, or 100 data, or 150 data, and do a sampling. You cannot decide like that. To decide based on which kind of sampling technique you are going to use, whether you are using the probability sampling, or a quota sampling, or a simple random sampling, or a stratified random sampling, or systematic sampling, whatever kind of sampling, there are hundreds of sampling techniques and sampling methods. So whatever kind of sampling method you want to apply, right? Ideally, you have a particular formula or a mechanism. Okay, I'm not going to talk about the entire thing, but there is a particular way or a process you decide that particular process. For example, you have decided for a systematic random sampling. So if you apply the methods of systematic random sampling, so why you're telling all these things? Because if you understand all these things, only what I'm speaking, then only you'll be able to understand bagging, then only you'll understand random sampling. So that is what random sampling has a direct relation with statistics. That's why. Now, if you put a systematic sampling or a stratified random sampling, so let us take we are applying the stratified random sampling. So we have to apply the methods of stratified random sampling, and then in that, right, then in that you have a particular formulas to decide based on the population data how much of sample size you can actually take. Okay, this is what exactly sampling is, right? So, most of them would have already known this, right? This is what sampling is. But the sampling in bagging is different from what exactly you do as a random sampling or a systematic sampling. Why this bagging is different is what happens in the random forest is you actually here we are talking about sampling with replacement, correct? No? Now, what exactly happens is we select a sample, right? And as I said, we are going to make some 10 sample different kinds of samples, like sample 1, sample 2, sample 3, sample 4, like that we are going to make. Usually, for example, let us say if you have 1,000 data, maybe we are going for 100 data according to a normal sampling. But that is not the case in bagging. Bagging, what happens is even our sample size will be same as the population size. Yes, you would have heard it right. The sample size is also exactly same as the population size. That is what the magic of random forest. What happens here is exactly, since you are doing sampling with replacement, okay, so there is a high chance that a particular row, right, or a record might be selected multiple times. Okay, so because of this, what happens is not every sample will have all the observations in the sample. So for example, it might some 400 for example, 1,000 I told. Our first sample 1 will also have 1,000 observations, but it might be only 400 observations which are repeating multiple times. Some may repeating 3 times, or some may repeating 4 times, some may repeat 1 time or 2 times. So that particular record will repeat multiple times. Okay, right? So what happens if you do like this is the sampling will not know about the entire data. So biasness will not come in. That is what the main agenda of using a bagging technique. So here again, sample 2, if you take the sample 2, again for sample 2, you again take the 1,000 sampling technique, right? You don't do manually. The compiler itself will sample like that. Okay, because it will use the with replacement technique. Again, it will put it back, and again it will take one sample out. Again, it will make it. So like that, it will make 1,000, 10 samples. Okay, and then it will try to train. And each sample 1, which has 1,000, will build a decision tree. Again, sample 2 will build a decision tree on that 1,000 observations. And again, sample 3 will build a decision tree. And based on that 10 number of 10 samples, it will try to vote it out based on decision tree, that what is our outcome. It is a true or a false, or yes or a no. So for example, in that particular 10, right, 8 or 7 vote out for true, right, or maybe yes, right, the outcome will be a yes. So that is why random forest uses a voting technique. So to vote, it will build independent decision trees. That independent decision trees are not built on the data set. So what happens in decision tree is decision tree will build a decision tree on the only data set. It will not sample like this and it will build. So what happens is there might be bias, and some of the observations might take the some might take the extra noise also. Here what happens is not every observation is knowing about the entire data. So in that 1,000 300 rows might repeat, or 500 rows might repeat. Who knows? No, we cannot even tell it. No, so it's completely random, completely random. So it might be 500 each way is repeating, maybe 1,000 individual are coming. Actually that doesn't happen, right? Because when you sample from 1,000, when you are replacing it, it is very difficult that exactly you are going to choose individual records. So that is not possible. So what happens is repeatedly, a particular sample gets selected and the model is trained on, things repeatedly multiple times. This actually helps in building the model in a perfect way because it doesn't encourage or has any bias, right? And the data points doesn't know about the entire data. So by this method, what happens is the learning of the model will perfectly happen because there are multiple repetitions as well, and there are they don't have any contact with each other. Each sample is independent of each other. So like that, it's going to build, and it is going to build, whether you're taking 10 samples, it will build 10 decision trees, and it will try to vote it out on 10 decision trees. So for example, if you are building some 20 decision trees, it is going to build 20 samples. If you take, it's going to take the 20 decision trees. Based on that, it is going to happen. So this is what the mechanism of bagging. Now, this process, what happens, right? What I told you, that is basically called as a bootstrap sampling. Bootstrap sampling. It's not a normal sampling method. We don't take the same number of observations as the original data set as a sample. We never do that. But we only do in the method of bagging, where that is why it is called as a not a normal sampling, but we call it as a bootstrap sampling. Here we are actually, the number of rows will be exactly equal. Each sample number of rows will be equal to the size of the original data set. So that is how the sampling method is actually done. So next is, independent, as I told you, this is what I've already explained. And then we'll go with the majority voting part, and after building a tree. And each sample will build a tree independently. It will build a decision tree independently, right? So that is why, and then we'll go with the majority voting, and we are calling it as aggregation. So now understand, is there any independent formula or something like that in random forest? No. We are using the bagging concept, which is the bootstrap aggregation, and then we are applying the decision tree, right? So it is basically two different concepts or two different models which are bringing into random forest. So that is why if we bring two different models or three different models or four different models into a particular algorithm, those algorithms basically become an ensemble techniques, right? So those are called as ensemble techniques. So decision tree, you cannot call it as an ensemble technique because you are not merging multiple models, right? But in random forest, you are merging multiple models. For example, linear regression is also not an ensemble technique. Logistic regression is also not an ensemble technique because they are independent models, right? They have their own formula, they have their own methodology. They don't rely on a mixture of multiple models, right? So if a particular algorithm is actually depending upon multiple models to build its own algorithm and then predict, then it becomes a ensemble technique. So this is how the exact original data and then the classifier happens. Okay, so let us go to the here you may you may count the number of balls. I don't know whether it's equal or not, but usually what happens is each sample size will be the same as the original data. Okay, that is what basically bagging is. Right. So now, so here again I mentioned the same thing, which actually justifies what I actually told. So let us see one example here. From the actual data, there are different kinds of samples which I have taken. For example, like bootstrap sample 1, bootstrap sample 2, and bootstrap sample 3. With replacement, which means there is a high possibility that each sample won't contain unique data. Obviously, no, if you are sampling without replacement, right? Then definitely you can say that it will be unique. But if you are replacing it back, what if the second time also you take the same observation, right? So now the model, what happens is model 1, model 2, and model 3 obtained from this boot sample are trained independently. So the sample 1, sample 2, sample 3 will not, they don't have any relationship among them, right? It's completely unique, right? And the samples are unique of each other, right? But the data is not unique. It may, the samples might repeat multiple times. Sorry, the data points might repeat multiple times in that particular sample. So each model generates results as shown. Now the happy emoji has generated when compared to the sad emoji. So in the final voting, whatever has the majority, we go with that particular emoji in this example. So here you can see. See here, three models are generated. In those three models, first model and third model has generated a happy emoji, right? And the second model has generated a sad emoji. So if you vote 2:1, right? So 2 votes for happy and 1 vote for sad. So we are going that the outcome, we are predicting that the majority voting and the outcome is a happy person. Okay. Let us now see what is the boosting technique. Okay. So now, right. So now, since we have already seen what is a bagging, let us see what is a boosting also now. So again, boosting is also a concept in Ensemble learning that we have already seen, right? And we have learned that two kinds of learnings are there. One is the bagging and one is the boosting part. Now, what is exactly boosting? So it is basically a model which combines all the weak learners in the data. Okay. So now to understand what is this, okay. So bagging, the samples are independent of each other. But here, the in boosting, what happens is we are going to merge even the samples as well to make, because independently each sample is a weak learner. Now let us go step by step. So it is done by building a model by using a weak models in the series. So there are several boosting algorithms, right? And the very important one, or what you would have heard, right, is something called as an ADA boost. Okay, we have something called as an XG boost, ADA boost, right? So this was the first successful algorithm which is actually implemented for a binary classification. So basically, ADA boosting is nothing but combining multiple weak classifiers and making into a strong classifier. So that is why, since you are merging multiple models again, right, we are going to call this as a ensemble techniques. Now, let us keep that boosting part, for next sessions. Why? Because we will see different boosting algorithms also. At that time, let me explain it in very detail. Okay. So first of all, we'll see the random forest part. Why? Because random forest comes into a bagging. So that is why in detail I've explained what is a bagging concept. Now, in this, the first step is basically about, subsetting into different data points and constructing a decision tree for each and every sample or a subset. Then we have n random records and m features containing a data sets. And then we construct individual decision trees for each sample, as I already told you. And each decision tree will generate an output. We consider the final output by on majority voting for classification and averaging for regression. Okay. So because for classification, we can go with the majority voting. For example, 10 trees are there. In that 10 trees, which the most number of trees, whatever gives the majority, we are going to consider. For example, if we give 5 and 5, for example, let us say it's a yes or a no scenario. We got 5 for yes and 5 for no. Then, we are not able to predict, then we are not able to predict using the classifier. So then we'll go with more samples, right? And then we try to increase the sample size. By instead of 10, we will do 15 or 20 or something like that. And then we try to apply through different. Okay. So we'll try to increase the size of the the samples what we have taken where the training is done. So again, we will try to match. So again, if that doesn't happen, we try to increase and try. Okay. Now, the same, the outcome is for classification particularly goes for the majority voting. And for the regression part, we have, see, regression, what we are doing, we are actually predicting the outcome variable for particularly, I can say a numerical variable, correct? No? or a continuous variable. So here we'll get different values of y, right? So all the values of y will be taken average. Okay. So for example, there are 10 trees. In that, you have y is equal to 70, y is equal to 50, y is equal to 20, y is equal to 80, y is equal to 60. Like that, we might have some 10 different values. So all the values average will be taken, and that value will be used as the outcome which you can do. So that is why we say averaging for regression and majority voting for the classification. Now, let us see as one more example. So consider the fruit basket as the data shown in the, here I'll show you. Okay. So this is the fruit basket. Okay. Here you can see a fruit basket, right? Now a number of samples are taken from the fruit basket, and an individual decision tree is constructed for each sample. So each decision tree will generate an output as shown in the figure. So you can see here. Okay. And now the final outcome is based on the majority voting. So in this below figure, you can see that the majority tree apps for an apple compared to a banana. So we take a final output as, right? So now I think you would have had some clear understanding that how the random forest actually works. So here you can see the majority voting is with the apple. So the product, what is actually, the outcome will be the final class will be a apple. Okay. So more often than not, random forest gets the outcome right. Trust me. It's a very, very good algorithm when you implement in the real time. Trust me. Okay, so don't believe, when you see, when you go for majority voting, you may see 6-4 voting, or 7-3 voting. So sir, it is classifying three outcomes wrong also. But don't worry about what is happening inside the random forest, right? Don't worry about what is happening inside the random forest. Whether random forest is able to classify or predict a continuous variable for regression, whether the values are getting you correct outcomes or not, that is what you should be bothered about. And most of the instances, random forests gets it right. Okay, so only the outcome you should be final class. So whatever the inside trees are showing, why you are bothered? We are not bothered. Let us leave, right? Just since we have to know that how this works, we are, concerned about that. But when you think logically, we should not bother. Only the final outcome. So definitely, when you see, when it sees a particular apple and it's predicting as an apple, so the outcome is correct. So that is what actually matters. Okay, so before going into this thing, let me take some questions. Let me see anybody has any questions. So I'm giving a couple of minutes. So if you don't have any, we'll move ahead. If you're having, please ask. Okay, fine. I'll make sure it is uploaded. Yeah. Actually, yesterday, I've shared the project as well, actually. But I think the other projects I think I've not shared. I'll tell ma'am to go upload. Yeah. So apart from that, anything else? Let me see here also. Sure. I'll tell. Okay, I think there's no question. I think we can go ahead. Okay, fine. Right. So let us see now. Yeah, since you don't have any questions, I'm continuing. Let us see the important features of random forest. Okay. So what is the important aspects which are involved in a random forest? So basically, random forest is distinguished by several features, right? And in that, let us see what are the important things. One is the diversity. So each decision tree in the random forest is built from a different subset of data and features. So this already we have understood, right? So the samples are different or independent from each other. So there is a diversity when it comes to building a decision tree. So this diversity helps in reducing the overfitting and improving the model's generalizations capabilities. So since there's a diversification, or the samples are diverse from each other, so what happens is it also helps not to have overfitting also, and improve the model generalization. So it works well, by following this kind of technique. So next is the robustness. By averaging the results from the multiple trees, random forest reduces the variance and improves the robustness of the predictions. So this is for the regression part. So the particular value is averaging out, right? So the variance also doesn't happen much. So handling the missing values, it can handle the missing values very well. And by using the splitting, proper splitting, or you can say averaging results from the other trees that do not have any missing values from the data points. So since we are taking from the original data set and it's the same as the and we are using the data set without the missing values, so definitely our samples also will not have any missing values. So the training part is also done extremely well. So next is the feature importance. It provides insights into the importance of each feature in the prediction process. So this can be particularly useful for feature selection and understanding the underlying patterns. Next important thing is the scalability. So random forest can be parallelized because each tree is built independent of the others, right? So all these things actually I've explained. So this makes it scalable to large data sets and high dimensional data. So this is well suited for data sets which are extremely huge. So you know using this technique is really helping to the model to learn, because not every feature is covered, right? Because the original data set has 10 features. The samples, all every sample will have 10 features only, right? And the original data has having some 1,000 observations. All the samples are also having 1,000 observations. But here replacement is there. In the original data, replacement is not there. That is the only difference. So versatility, it can be used for both classification and regression, and the algorithm is also effective for tasks involving categorical and continuous variables. So this also we have seen. So next is the stability. Due to the ensemble nature, it is less sensitive to changes in the training data compared to a single decision tree. Because if you are building a single decision tree on the entire data, right? So how much you can trust, right? So a lot of trust issues are there, when it comes to a decision tree. Here, you're not building one decision tree, but you are building multiple decision trees. So, sir, we build usually 5 to 10 decision trees. It's up to you. You want 15 samples, you want 20 samples, you can use n number of samples to train your algorithm. So this is one of the important interview questions as well. Out of bag error estimation. So out of bag, we'll discuss in detail also when we discuss the interview questions on decision trees and random forest. But since we are understanding what is this decision tree, sorry, what is this random forest, let us see also what is this error which comes into the random forest. So this is basically called as an out of bag or OOB, right? Now here, random forest provides an internal mechanism for estimating the model error without the need for separate validation. This can be done by using the out-of-bag error estimation, so which is not used in the construction of each tree. So once the model has been built, right? So it is basically validated using a separate validation dataset. It is not validated using an internal dataset. Okay, so that is in where it is called as a out of bag error estimation. So usually we have, when we are training and testing, usually we divide the algorithm and we train and test. But when you are actually validating, to be precise, we don't use the internal data set to validate. That is in where the out of bag estimation is actually useful. So these are a small screenshot I had. I just wanted to share for you to see the differences between a decision tree and basically a random forest. So basically, the main problem of decision trees is usually the overfitting problem, right? So that is actually taken care of by the this building into subsets which are actually based upon random sampling with replacement. So and taking this majority or average voting is actually helping it, and it is not allowing now to go to overfitting. So that isn't what the decision trees are missing or lacking when it comes to the random forest part. And a single decision tree is faster in computation, but when it comes to multiple decision trees, actually building a decision tree itself takes a lot of time. And here in random forest, we are building multiple decision trees. So you can imagine that building multiple decision trees will be extremely difficult, or it takes more time. Okay, so that kind of patience we have to have when we are building a model, particularly in a random forest. So the compilation takes a lot of time compared to a decision tree. Okay, right. So now let us understand about the hyperparameters inside a random forest. So there are certain hyperparameters which actually are used in the random forest. So there are, so let us see some of the hyperparameters which are used. The first one is the n estimators. So basically what is this is the number of trees the algorithm builds before averaging the predictions. So this is nothing but if you go for a if you go for a regression model. So, averaging out that particular whatever, values it has given. For example, 10 trees. So 10 values will average it out. So that is basically called as an n estimators. So next thing is the maximum features. So maximum number of features random forest considered before splitting a node. Okay. Now this is one more important hyperparameter which has to be considered. Okay. So next is the mini sample leaf. So which this is basically determines the number of leaves or number of the nodes actually a particular tree actually has. That is what we are calling it as the sample leaf, where we are trying to denote the number of leaves required to split the internal node. So that is we try to minimize as much as possible. So next is the criterion how to split the node at each tree. Which kind of method we are going to use. Either it is entropy or Gini impurity or a log loss. What kind of method we are going to use to do this. So next is the maximum leaf nodes. That is maximum leaf nodes in each tree. So now to increase the speed, the most important thing what we are going to do is the something called as an n jobs. So this actually tells us how many processes are required. If the value is 1, it can only use one process. If the value is -1, there is no limit, right? So that number of processing a particular model can do. So next is the random state. So random state, you already know that basically this actually controls the randomness in the data. Usually random state we go with 42, right? That is a standard number what we go with them. So this model always produces the same results if it has a definite value of random state. So and receives the same hyperparameters and training data. So the usual number what we go is the random state 42. So this out of bag, error. What is this? Is OOB means out of the bag. It is a random forest cross validation method. So we have seen no for validating we are using the OOB method. 1/3 of the sample does not train on the data. Instead, we use it to elevate its performance. So we call these samples out of bag. So it doesn't even know, that how the model is built, what has happened in the model, and how these particular data points are actually used. So it completely these particular data which we have segregated is unknown from the original data which we are actually where the model has actually been built. Now let us quickly see what is the advantages and disadvantages we have when we build a random forest algorithm. So what are the advantages we can see is we can use the random forest random forest for classification and regression problems. So it basically solves the problem of overfitting as output is based on majority voting or averaging. So it performs well even if the data contains missing values or null values. Each decision tree created is independent of the other. So it shows the property of parallelization. So it maintains high stability by taking the average answers from large number of trees. So these are some of the advantages what random forest actually brings to the table. So next is it maintains diversity because each decision tree does not consider all the attributes, although this is not true for all the classes. It is immune to the curse of dimensionality. So since each tree ignores some attributes, the features space is reduced. So we don't need to segregate data into training and samples because 30% of the data is already taken and will remain unanalyzed by the decision tree created from the bootstrap. So we saw no 1/3 of the sample actually is automatically segregated. Okay. So disadvantages, see the advantages and see the disadvantages. Okay. So yes, so obviously the decision trees uh, has, building of a decision tree is taking a lot of time, right? The same for even one decision tree takes a lot of time. Think about multiple decision trees, right? So it takes even more time and more complex, correct? No. So obviously, the random forest will take a lot of computational time and a lot of training time is required, and complexity can be huge, right? This is the only problem I can see from random forest. I was never disappointed by using a random forest because most of my outcomes, my predictions and outcomes, the random forest got it right. So, I never felt disappointed that, it's not, building me a perfect model for my prediction. So it never happened actually. So, almost I can say it never happened. So such a wonderful and a lovely algorithm, random forest is basically when it comes to the prediction part. So now, anyway, we already have seen what is the Gini index. Okay, so let me just go through because whatever applies in decision trees, the same concepts actually also apply in the random forest as well. Only thing in random forest, we are using that, bagging and we are using multiple decision trees. Apart from that, all the decision tree concepts actually come into the, the random forest as well. So particularly one such feature is the Gini index, right? So this is basically, this is calculated particularly for, I can say, so entropy, entropy is basically used for classification problems, right? And if entropy is not, giving you much results, we go with the information gain. So that also we have actually understood. So, but Gini index is basically, this Gini index is used for regression problems. Okay, so this is how we are going to use the Gini index. A particular value which is having a numerical value, we are going to use the Gini index. Okay. So this is a formula for basically Gini index. So here we how much of which particular I can say which particular feature, right? We are going to take to split that particular node, right? So for that we are going to take the very important method, which is the Gini index. Okay. So this is basically this Gini index actually tells you the impurity in the data. Okay. So this is a very small formula. You can see that 1 minus summation I is equal to 1 to n pi whole square. Okay. So in that pi, you have two kinds of things. One is the probability of a positive class and the probability of a negative class. Okay. So here you can see with an example, right? And loan amount and the loan status. Okay. So here you can see if the loan amount is greater than 200. So there are two outcomes. One is too bad and one good. And there is also one more outcome, one bad and one good. Okay. So for this, how do you calculate the Gini index? Is basically applying the formula, right? So for the first feature, we are going to apply with positive and negative. So whatever is positive, right? So there are two bads and two bad and one bad here. So three bads and two good. So we are going to apply that 1 by 3 positive and 2 by 3 negative. So the same thing applies here when we calculate the Gini index. We are going to get the value. So on the right split, you can see that there are equal number of splitting, which is one bad and one good. So it is 1 by 2 and 1 by 2. So we apply, we get the Gini index. So here you can see 0.455 and this is 0.5. So based on that, we calculate the weighted Gini index as well. So which is the values what we have. So here you can see three cases here and two cases here. So 3 by 5 and 2 by 5. Okay. So anyway, we have discussed all this, no issues. And here we can apply the formula. Okay. Weighted is basically the probability into its particular index, whatever it has, 0.4555. And for 2 by 5 case, 2 by 5 case, we are using the 0.5 Gini index. And we are going to get the weighted Gini index as 0.4733. So the same thing happens, here, when we actually calculate, right? And how many ever features we have, we are going to calculate for all whatever possible decisions which can be taken. And we obviously know that lower Gini indexes means lower impurity. So that is what basically the Gini index is about. And one more thing, metric, and which we have already have spoken about yesterday. Okay, I'm not going to go much into it because we have already have discussed when we discussed the decision tree. So one more important thing is nothing but the entropy, right? So entropy is basically it basically measures the impurity. So Gini index measures the impurity for the I can say numerical variable or a continuous variable, and entropy is basically used to measure the impurity, right? Particularly in the classifier or a classification model or a classification data or a categorical data, I can say. So here the formula we have seen also yesterday, minus pi into log pi, right? So positive case and a negative case we are going to take. So we usually use the Gini index for so it takes shorter period of time, no logarithm term. But usually if you have to go with the logarithmic term, that's why we are using the boosting algorithms. That's why many boosting algorithms use the Gini index as their parameter, because Gini index, what it does, it doesn't have this, we can also use this for classification also. And since it doesn't have any logarithm values, most of these boosting algorithms are using the Gini index than the entropy. So one more important thing to note here is there are equal number of both the classes in a particular node. Then Gini index will have its maximum value, which means that the node is highly impure. Okay, because high Gini index tells you that there is more impurity in the data set. And because we have already seen that Gini index should be lower. So if the Gini index is lower, then the impurity is low in the features which we want to segregate. So this example yesterday we have seen as well, right? So Lucy and Titanic. And here, yesterday I think I've taken 5-4 kind of thing. And here, if I'm taking 5 votes for Lucy and 5 votes for Titanic, it is very difficult to judge which kind of or which movie has to be chosen, in this scenario, right? So now applying decision trees in random forest algorithm, how do we apply, right? So the main difference between these two is basically the random forest is a bagging method and uses a subset of the original data set to make the predictions. And this property of random forest basically helps in or you can say overcome the overfitting problem, right? So instead of building a single decision tree, random forest builds number of decision trees with a different set of observations, right? So one big advantage of this algorithm is that it can be used for both classification and regression. And now let us see what are the steps involved. So we make different subsets of the original data set, and then we apply the sampling techniques, right? For that, we apply the feature sampling, and we select the rows and columns what we need with replacement and create subsets for the training data set. So in this step 2, we create an individual decision tree for each subset we take. So each decision tree will give you an output. So final output is used or taken as a majority voting in a classification and averaging it out in the regression problem. So this is the working of a random forest. Okay. So this is a example what we can take. So I think mostly we are done with the theoretical part. Okay. So let me stop here. Let me take your questions. Then we can go with the practical part. So just I'm giving a couple 2-3 minutes. Um, so any questions if you have, you can ask me. Um, or else you can open up your your Python Jupyter notebook and you can load the data set. We will see the implementation of random forest by using that data set. I think possible please take one project like we can use the CSV file and the image data. You'll be using the image data also, Neha. Yeah. We'll do that also. Yeah, there are many more data sets to come and many more methods to come as well. So as far as I remember, we are in the still in date 6, right? So a lot of data sets and concepts are yet to be covered. So tomorrow we'll talk about the interview questions on decision trees and random forest. So random forest and decision trees will discuss the interview questions. There are a lot of questions which come up on decision trees and random forest. After that, we'll go with the SVM part. Okay, SVM is also a very important method. So I'll try to cover as much as possible. Okay, so whatever we are, I want to cover, I'll give you the best what so that you can try and explore and understand the concepts. So anything, any questions? I've shared the link also again of the drive link of the data set. So maybe you can have a question. I think so. If you are having the data set, I guess no issues. No questions also much. Only a couple of questions I've got. Hmm, should be fine. I think we can go with the analysis part. Okay. So let me fine. So let me share. Okay. So let us start with the project. Okay. The same data set what I have used for decision tree, I'm taking it for random forest as well. Okay, because it's the same kind of data. And I really like you to see, that it's been implemented for a financial data set because as I already told you, particularly for this field and this kind of predictions, random forest and decision trees play very vital role. Okay, and let me explain this, but before that let me share also in the chat. Okay, so I've shared this, you can also see. Fine. So now let us start. Now, so by this time you would have already understood why we use pandas. So pandas is basically for reading a data frame, right? And we are using NumPy particularly for arrays. And then we go with the matplotlib, right? Uh, we use the matplotlib for the data visualization and Seaborn for again data visualization, which is advanced visualization. So then we use this grid search CV and training and testing the data. Okay, so these are the two which we are actually trying to use in the model selection. Okay, so I think we can remove this, not required. Okay. Okay, I think it's fine. Okay, so now we are trying to use the ensemble methods. Let us take the gradient boosting classifier as well. Okay, and then in the tree methods, let us implement the decision trees. Okay, and since we are applying a classification problem, the metrics, I just mentioned this also. Okay, here. So the metrics we are going to mention, which is the even I can actually put this here itself. Okay, I'll just put a comma because all these are under metrics. So F1 score, classification report, AUC, ROC curve, recall score, and confusion matrix, everything actually comes under metrics only. So I can remove this and I can put it here only. Right. So now we have all the metrics which is involved, right? And we can use this linear model, and we are applying the logistic regression also. Let me implement that also. And ensemble technique, we are applying the random forest classifiers. So this is for ignoring the warnings. Okay. So I think I'll give you this. I made some modifications from the older one. Okay. So I can use this one. Okay, so this is about the libraries part, which we are actually having and what we actually try to or want to implement. So going down to the data set, what we have loaded, right? So it's the same data set what I've shared with you yesterday. Okay, the link also is the same. And once we load the data set, we can view the head of the data set, which is df.head, right? So if we use this df.head, what will happen is it will give you the head of the observations, right? So it will give you the head part. Okay, I think everybody is fine with this, uh, you know, part of, the libraries, what we are actually implementing, right? The modules and the libraries and the functions, you are thorough. Okay. Now, if we go down, the loading part of the data set, and the next thing is the head of the data, right? So here you can see that we are implementing the the first five observations, right? So we can see 0, 1, 2, 3, 4, 5, right? So here you can see the first five observations. And then if you go down, you can see the entire data frame. Okay, so this is completely optional. If you want to put, you can just put the data frame. Okay, if you don't want to put, not required. Okay, it's an optional function. Okay, now if I go down, right, the next thing what I'm trying to do is, okay, here I'm taking a sample. Okay, now what I'm trying to do is I'm using the training and testing. Okay, but now we will do multiple things. Okay, we'll go to that EDA part, but just before that, okay, but just before that, I just wanted to show you how we can actually take the sample. So we have huge amount of data, right? So here see, in this data set, if I want 550, it is basically it's 10,000, 10,000. Yeah, this is basically 6,36,000, right? If we want 5 lakh as a sample data, we can give the test size as 0.92. That's what exactly it's calculated. And you can see that we are getting 5,000, sorry, 5 lakh as the sample. Okay. And random state is 1, 2, 3, 4 is basically what is used for this random forest. Okay. And here I'm using the function which is stratify. Okay. So we are going with the stratified sampling. Now here you can see that the shape is basically just posting this also. So basically, if you see now, if you use this number, okay, so I mentioned it here also. If you use this number, we are going to get 5 lakh. It's basically 92% of the data. Okay, but I exactly wanted 5 lakh, so I just used it as a sample to show you guys. Okay, now if I just go down, okay, now for for training the data, if you want 3 lakh, you can use this. For testing data, if you want 1 lakh, you can use this. Okay, so this is basically to show you that this is how we actually do it in the random forest. So we are going to implement it by taking a particular size to train and test the algorithm. Okay, I'll just copy the code and then I'll send you. Then I'll implement the test shape as well. Okay. So this is just to test out that if we want to give a particular size, what we can actually do. Okay. Now let us go a little down to understand what is exactly happening or what we should do in the process. The first one in the EDA process, EDA is nothing but the exploratory data analysis. Exploratory data analysis. In that, the first step, what we are trying to do is we are trying to find the information about the data. Okay. So here on the training data set, since we have already divided it into 3 lakh for the training data. Okay, we are splitting the data set here and 1 lakh for the training data. Sorry, testing data and 1 lakh for the validation data. Okay, that is what we are trying to do. And here we are keeping this other 1,30,000 again to validate later. Okay, so we are using only 5 lakh. In that 5 lakh, we have made a split. Okay, so we have made a split for 3 lakh, 1 lakh, and 1 lakh. Okay. Now we train on the this 3 lakh first. Okay, because that is what we have divided into a training data. Now let us start by applying the functions on the training data. Here you can see there is no null value, and whatever are categorical variables, we are getting a float. Sorry, we are getting an object, and whatever is a numerical value, we are getting a floating value. So here you can see step is an integer. Okay. Maybe you can type if you're not able to, or else you can just listen. So that is also fine. Can you ask others? Okay. So I think maybe not possible, I guess. I'm not sure. So maybe, or else I can do one thing. I can share you the IPv1 by NB file. Maybe you can use that. That should be better. Just give me a minute. You can just download an IPv1 file. Okay. I'll share you that, Neha. No problem. Just give me a minute. Yeah. I'll just share it. Yeah. Yes, Om Prakash. Om Prakash. I've shared that also. You can just yeah. Here, see, to import, here you can go to the, here you can go to your page, right? And here you can click on upload. Okay. So you'll get this, you can upload it. Okay. So this IPNB file, whatever I shared, I think you can download it. Okay. You can just click on upload here and you will show this online fraud. Okay. So whatever I have shared with you. So you can just click on that, it will show. Okay. So maybe I'll show you it. Just click on upload. Okay. Just click on that and it will show and you can click on upload. It will be easy for you to upload. Okay. Yeah. So then you can see that imported. Only thing what you have to change is after you upload is this link. This address you have to change of your data set. So because this is my address of my laptop. So I have it in my downloads and data sets. So this one, if you can change, which is by giving the address of your laptop. So it will be easy for you to view the data set or you can read the data set. So maybe everyone can upload. I'm just waiting for a couple of minutes. So you can load it and you can just go to this 11th line, what we are discussing. Okay. I'm not going to share the code in the chat. I think you're not able to copy, so it doesn't make any sense. I'm not sharing it there. You can just use that IPv1 bail. So what I'll do is the same thing. So I'll share the dataset link and this IPv1 file during the session before I'm just going to start. Maybe or at the middle once the concept is done. So you can just download the dataset and you can load the IPv1 file and change the location of yours and you can run it along with me also to check. Okay. So why I run and keep is basically to easy for you to show, right? Sometimes some of the compilation takes some time to compile. So we have to wait. Uh, okay. Okay. So I think everybody would have done. I'm just giving give a few. Okay. So let us continue what we are doing. Fine. Here I have started using this train data set, what I actually have given. Okay. So in that, which consists of 3 lakh data set, right? And I'm using this train to check the info, whether there are any null values, and to see the data type of that particular columns or features in the data set. Now, anyway, I know here that there is no empty values, but just I'm just cross verifying using this is null function. Okay, so if we use this is null dot sum, we are going to get whatever null values are there in any feature. Okay, so I think here you can see that there is no null values in the data set, right? So let us go to the next part to understand what happens. The next thing is dropping the duplicate values. Okay, so we are just giving, you know, we are giving that if something is there, okay, keep, drop the duplicate part. Okay, so in place true is basically, it will apply it in the original data set. Okay, so the data set which is loaded into Jupyter, in that data set, it will make the changes if you keep the in place true. Okay, in this data set, not on the Excel file which you have downloaded, not that. Okay, now again here we are seeing the shape. Okay, so there is no duplicates here. Okay, so using this function doesn't affect you anything. Okay, so better to use if there are any duplicates which are not unique. Okay, and you want to drop them. So here you can see there is no duplicates here. So there is all unique elements in the data set. Now, if we go to the next part, which is the describe function. So describe function basically gives you the description, which is the which actually gives the description of the data, particularly the numerical values. Okay. So if it is also calculating for the non-numerical values, don't if something which is not for example like a step. Here step doesn't mean anything here, and for is fraud and is flagged fraud also it doesn't matter. Okay, so you can you can identify it for the new balance, old balance original, and old new balance original. So for this, for amount, you can actually understand the describe function. So particularly which are not categorical, particular numerical values, describe function works well. Okay, now let us start building with a plot. Okay, the most important thing what we're going to do now is building a plot. Okay, so this is basically to calculate the fraud cases in the entire data set. So in the data set, what we have, this will identify or this will give you the total number of fraud cases. Okay, it will give you the number of fraud cases in the entire data set. So for that, the most important function which we basically use is the count plot. So count plot actually what it does is it will count the number of things what are exactly there in the data set. Okay, so here you can see that who is having fraud is fraud, or the cases which are fraud are more. So this is what here it shows that the classes are imbalanced. Which are not fraud is only 387, and what is fraud is actually around 2,99,000. So what is happening here is there is a lot of imbalance in the data set. Okay, so here this themed and all this all extra function, and this gives the figure size, how much of figure size you want, you can give. You can change it if you want a bigger size, you can give 10,6 or 10,8, right? 12,6 or 12,8 or 12,10, something like that you can give. So there is a lot of imbalance in the data. Okay. Now the next part, why we are next we are building again a count plot to count that something which is flagged as fraud. Okay, so basically is fraud, and which is actually identified as fraud. That is what our data set actually has. Correct, no? So here, when we implement this, it is counting that almost everything is basically flagged as fraud. And again, here you can see a lot of imbalance in the data set, right? Next and the foremost thing is here we are going to build a subplots. Okay, so for what we are buying, we are actually building the subplots. We are actually building the subplots for the the different kinds of transactions what we have done, or you can say different type of payment methods. Right, correct. No, that is a correct. That's a correct word to tell you, right? So, or you can say here in crystal clear words, it is basically the transaction type. So whatever transaction type are there, I think we have 5, right? So we have actually given as 1, 2, 3, 4, 5 in the yesterday's decision tree project. So here cash out, payment, cash in, transfer, and debit is the 5 different. Okay. So those are the 5 different, those are the 5 different kinds of transactions what we actually have. Okay, so we are using the count plot to see what transactions are actually more. So you can see in the plot that cash out and payment is mostly more. Cash out is basically more, and the second best is the payment. And then we have the third one is the cash in, right? And then we have the, uh, you know, then we have the transfer, and then we have the debit part. Now, right. So now let us see a very important function which is called as the cross tab. Okay. So what does this cross tab actually gives us? It segregates the based on which kind of feature you want to see the segregations based on that particular classifications, or you can say the classifiers or the categorical variables. For example, in this type there are 5, right? So cash in, cash out, debit, payment, and transfer. So in that, if you use this cross tab for that particular column, you can see that how many zeros are there and how many ones are there, so which are classified as fraud and not fraud. Okay, so you can see that particular. So basically, cross tab is nothing but a cross tabulation, or you can say a table format to see the things what are actually happened in the data set. Right. So now let us go forward to identify the count plot for the fraud distribution. So now if you run this code here, as you can see, I'm again mentioning the count plot, right, for the particular attribute where I want to identify that how many fraud transactions are there. Okay, so I can see 192 and 195 particularly for which is my is fraud, which is 1. So 1, what is 1? 1 is basically cash out and transfer. So in the type, so in the 5 transactions what we have, fraud occurs only in 2 of them, right? Where transfer, where money is sent to a customer, fraudster at cash out, where money is sent to a merchant who pays the customer. So since we have these 2 things, cash out and transfer, maybe I can just go up. This should actually help you. See, this 192 and 195. See, okay, there is no fraud in cash in, debit, and payment. Right? Yeah, I should have told you this. Then you would have understood very easily. So in the table above, that's why we have actually built a cross tabulation. So in the table above, you can see that the fraudulent transactions are basically happening in cash out and transfer part. Correct? No, that is why here we have given in that is fraud case, whatever is 1, that is in 1 cases, that is 192 and 195. Correct? No? So for that, we have built this plot. So now it shows that the fraudulent transactions is 192 and 195. The same what we have done in the cross tabulation. Okay, so cash out and the transfer part. So cash out and transfer. So this is where the uh, you know two kinds of frauds are actually happening in this data set. Okay, so let me move forward. So next step is to identify, right? So how many here we are actually giving that whatever is equal to 1 is basically a fraudulent transaction, right? And whatever is 0 is a non-fraudulent transaction. Okay. So now let us see that the transaction hour. Okay, because we have the step also, which is in the first column in the data set. Okay, so in that first step, which is actually should be divided by 24 because it is basically a day. Step is nothing but a day in which the process is happening. So we have to identify which transaction hour they are actually happening. So that is why we have built, we have used this particular function. Now, what is the use of this function is here we can build a graph. Okay. Now, once we build this, transaction hour, right, we can see that, by this histogram, here we are building a histogram, right? So when we are building a histogram, right, and we have given the bins as 50. So 50 distribution points we are giving. So when we build a distribution plot, you can see that where the maximum transactions are happening on which hour. So it is basically occurring after the 10th hour mostly, or you can say 9th hour. From 9th hour, the transactions are actually occurring more, right? So to do this, we have done this, building this step that, divided by 24 because the step indicates the time in which the transaction has actually been happened. Okay, at what time it has actually happened. So that we can do it by constructing a histogram. We can see the distribution of that particular hour where the transactions are or have happened. Okay, so moving a little bit forward, and now let us see the distribution of fraud also. And here, if you see at which transaction hour the frauds are occurring more. Now, at this hour, after 9 o'clock and something, the transaction is very less. Sorry, the transactions are more, but the frauds are less. That means in the early hours, the frauds are occurring more in this fifth hour, morning 5 a.m., 4 a.m., 6 a.m., 4 a.m., 3 a.m. So at that particular time, for that we have built the this graph to see that at what time basically the at what time basically let's put like this. You can see now, yeah. So at what time basically the fraudulent transactions are actually identified. Okay, at which hour they are basically identified. That is what the distribution plot is basically telling you. Okay, so now let me tell you. Yeah, so here is my report of my analysis also. So another analysis that can be interesting at which hour of the day the fraud attackers generally happen. From a step variable, we can get the hour of the day. So the below plot shows you that close to 20% of the transactions happen between 4 a.m. and 5 a.m. are fraud transactions. So that is why I've showed you the fraudulent transactions are basically near this time 3, 4, 5, 6, but more are occurring between 4 and 5. Right? That is what the analysis is here. So 4 a.m. and 5 a.m. Okay, so at that time we can alert the customers that be careful uh, because of the fraudulent transaction. So we can alert the customers as well, and bank also can make sure by this analysis that the fraudulent transactions are occurring at that particular time. Okay. Now going to the next part. Here for the transaction hour, we are converting into an object type now. Okay, to see that which transaction hour here, how the average transaction amount is actually shaping out. So now by this graph, okay, so what can we understand here? We can understand that at which transaction hour, right, how much of transaction is basically happening or which amount of type of transaction. So it might be a cash in, cash out, right? It might be a debit, it might be a payment, and it might be a transfer. So for that, we are going to build a graph to show, right? So basically, this is a line plot. Okay, it's a line plot to show that where the changes have occurred or how the transactions are happening over the time. Okay, so going to the next part is constructing a plot to see whether about the amount and the balance. So here you can see there is a positive you can see this line, okay, how the data points are actually placed. Okay, so what is happening here is what the plot is basically it's a scatter plot, right? You can see it here. So it's basically a scatter plot, correct? No? So in the scatter plot, you can see that what is happening by my analysis is the above figure represents the illegal money, right? So here I have mentioned the fraud money, fraud transaction, and the legit transaction. So now what you can understand is the illegal money and how to increase it until it reaches the permissible limit of transfers per day. So permissible limit is transfer $50 at this amount. The customer cannot transfer more than his balance until 24 hours is completed. Okay, so this will actually prevent the more fraudulent transactions. So you would have observed even for example in India you have a UPI payment limit of 1 lakh per day. So you can only transfer from one account to the other, not more than 1 lakh. So if you want to transfer, make more transactions, you cannot do it. So this is also a way to prevent fraudulent transactions as well, right? So even in your bank website, you can actually build. For example, you don't want to transfer money more than 25,000 or 35,000 or 50,000. You can keep a limit to a particular payee or a particular person. So if you're trying to transfer more than that, it will show that alert. So then you can if you are authorized user, you can actually change that you can give that permission to send more amount and all. So this actually will also identify if somebody's because they don't know how much of transaction limit you have put, right? So this is where the things where the transactions or to identify the fraud transactions actually can be limited, right? So for understanding this, where the things are happening and what the implementation part has to be done, that is what the main aim of this project is. That is where the online fraud detection we are using applying the random forest. So next is going down. Here we have the feature engineering part. Okay, so here we are dividing the first part, which is the transfer divided by the cash out. So here what happens is we are trying to understand that whether we are trying to calculate properly. For example, what is this calculation in 28 and 29th line? I'll tell you in a very brief way. So this what exactly is, for example, if today you are sending 100 rupees or 1,000 rupees to a particular person, right? The amount 1,000 rupees has to be debited from your account, and the same 1,000 rupees has to be credited, right? So you should not get that for example, like 1,000 gets debited and that same 1,000 doesn't get credited. So it is an error in transaction, right? So that to identify that, we are trying to identify that if somebody is sending a certain amount of money and whether it is actually going to credit into that particular person or not, whether it is the same amount has been credited correctly or not. So if it is credited correctly, fine, it is good. Okay, so it has performed or worked well. So to understand this, we are going to understand or we are going to do this feature engineering part. So for this, we are going to create a dummy variable. Okay, so for this dummy variable, we are going to train using this name. Okay, name of the destination is flagged fraud type and transaction. So this is what the training is mostly is happening on. Okay, now here, so these are, yeah, so these are actually dropped from the training part. That is what we are trying to do. Okay, now the only things what we are actually doing it in, particularly in the white train, is nothing but the dropping the we are using the fraudulent transactions, and for the X train we are dropping the fraudulent transactions. So if something is fraud, we are dropping from the X train. That means we are creating is fraud as a dependent variable. So we are giving that is fraud column to a y train. That means y variable, okay, or a dependent variable or an outcome variable. So rest we are all keeping inside the x values or the independent variables. Now for the data set, we are trying to use that we try to identify again. Now the next important part is what we are trying to do is here again the same thing we are applying for the same values, which is to identify between the transfer and cash out. Okay, so the same formulas been applied here where we create the dummy variable. So what exactly is happening again is same thing what we are doing here. Okay, right? The same thing we are doing here. Okay, but here what we are trying to do is we are going to have as X train and we are going to have is fraud as a Y train. The same thing we are doing it for the validation dataset. Val is nothing but a validation. Okay, so it's for validation dataset. So same process we are applying for the validation dataset. So even for validation dataset, for example, you train the Y variable as is fraud. So even the validation dataset should have is fraud as the as the validation part, right? Or else how you can validate. So the same things are actually applied. You can see exact same things only we are applying here. It's not at all different. It's the same thing that we are applying for the training data, and here we are applying for the validation data set. It's exactly same. Okay, so what we are trying to do. Okay, so now next thing is we are using the random forest classifier. Okay, so how to use this random class classifier is that's a very easy thing. So I'm defining the random forest classifier. Okay, so here for the random forest classifier, what I'm trying to do is I'm trying to train using the X train and Y train. So I want to train both the training algorithms, right? So I want to train for both the variables, sorry, X and Y. And then I'm going to use the X train for prediction. Okay, and after that, I want to build a report. Okay, this is for the training variable. Okay, so here I'm using only training part. Okay, and I'm going to build a report. Okay, for the training part, which is X train and Y train. I'm training it, right? And for that Y train, what we have trained, we are predicting the values using the classifier random forest. Okay, so here you can see the precision recall, F1 score, support, and all those values. Okay, here you can see the confusion matrix also. Okay, now the next part is for the validation dataset. Now the same thing I am applying for the validation data. Okay, so it's exactly same what I have done here. The only thing what changes here is you will get the validation data here instead of the training dataset. So here you can see we train on this, but we use the validation dataset. Here, see, we are using the training dataset. Correct? No, here we use the validation dataset. Okay, and for that validation dataset, we are using the Y predict, or we are predicting the values based on the dataset. What can be the values? Okay, and we are building the confusion matrix for the validation data. Okay, here you can see the precision recall F1 score. Okay, and support for that particular terms. Okay, and next we will use by passing the testing data set. So the same thing what we have done, right? This 38 and 39 is exactly same what we have done for the testing part. Here also, here for the validation, we have given the same thing what we have given for the right training data. We have concatenated, created dummies, right? You can see it here, right? So we have given the transfer and cash out, right? The same thing for training what we have given. So this is basically called as a feature engineering. So what we have given for the training part, right? Using this formula, correct? The same thing we have given for the validation also, correct? No, that's what I told. And the same thing we are giving for the testing data also. It's exactly same. You can just compare because you already have the code I've shared with you also. So you can compare it with. It's exactly the same. Okay. And the same thing what you are applying here, the random forest. Okay. For both the, I'll just go up again. You're applying for the training and X train and Y train. The same thing you're going to apply for the validation dataset also. And in the same way, you're going to apply for the testing dataset also. So it's the same thing only. Okay. So once you keep it side by side and you can analyze, you'll be able to figure it out. And for that, you are going to use the model to evaluate and to test whether the what is your prediction using the confusion matrix. And here you can get the precision recall and all. Okay. So this is what the random forest is basically what we have actually done. Okay. So and we have built a model. Okay. And it's ready for prediction and all those things. And it has built in a such a way that the accuracy is 100% here. Okay, one indicates that the accuracy is 100%. Okay, so this is what the support for the zero, which is not fraud, and this is for the support for the fraudulent transactions. Okay, so 129 here I can see 129, and here I can see fraudulent transactions of 387. So this is what this is the model basically is. Okay. So I think ma'am has shared the attendance. You can just go with the attendance and the feedback link. So any doubts on this? Anyway, I've shared the Python file. You can just go through that. Maybe you can come up with any doubts if you have tomorrow also. Because tomorrow we'll be discussing on the the interview questions, particularly on decision tree and random forest. I have many important questions. So we can discuss those questions and we can go move on to the next yeah, I'll give everything to ma'am. You can, yeah, she'll upload. Make sure she uploads. So anything else you have, you can just let me know. So I'll just share that things also. Um, Logistic regression, linear regression we have done. So for housing data set and all we have done for linear, right? So that also I'll share. Make sure you get those. Just share those. So let me also check for, yeah, I'll share those logistic and linear also. Think anyway, I'll just put here also all the Python files I've uploaded here. You can just download that also. Okay, for time being. Anyway, you have the data sets part as well. So but still I'll make sure that you get data sets as well as the Python files. Yeah. So I think these are the 4 projects we have done. Yeah. So online fraud detection using the random forest and decision trees, and apply attrition rate using the logistic regression, and housing price prediction for the linear regression. So for logistic, this is attrition rate. So these are the 4 projects we have done. Yeah. So more projects also will be coming. We'll be covering many projects actually. Okay. We'll do multiple projects on multiple data sets, not just using only 1 or 2 data sets. I think till now we have used 3 data sets. One is employee attrition, and for house price prediction for linear and logistic, and then this online fraud detection for distant tree and random forest. So 3 data sets and 4 concepts we have covered. So 4 algorithms I can say. So any doubts you can have, please ask me. Okay. Just or else we'll wind up in 2 or 3 minutes. Okay. Let's check. What's up? Any questions? I'll come to NLP, sir, later. Okay. We'll discuss NLP also. That is also in my agenda. I'll guide you how to, implement the text mining part. Okay. So I'll help you with that also. It's very easy actually, NLP. Maybe a couple of sessions we can do some NLP things. It's easy to learn, to understand also. I'll keep it very simple that what's the best things what you can do in NLP, how to implement this parts of speech tagging and all. I'll just keep it very simple for you to understand that what happens in NLP first, and based on that we can you can actually try and understand better later also. So till what we have done, I'll just share it to ma'am also as you can upload. Okay. Yes, 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 Neha, I'll provide. I'll provide. I'll make sure you get it. Sure. Fine, ma'am. We can end the session. Just you have anything you can just tell the students. I think no questions.
No, sir. Yeah, no questions to be addressed. We'll wind up for the day, sir. Thank you so much. We'll meet again by tomorrow, 7 p.m.
Tomorrow. Yeah.
Thank you, students. Thank you for joining the session. We'll wind up for the day. Thank you all. Good night.